Hello everyone, my name is Jim Garrity. Welcome to this, the third and final video in the Windjammer series. In videos 1 and 2 we looked at the foam dome that went over the top of the Windjammer and then the furry cover that went over the top of that. In this episode we are looking at the mechanical bit, the skeleton of the Windjammer, and we pick up the story just here on this desk. In fact, just there. 2 parcels arrived this morning and I've just unwrapped them, and it's the metalwork. We have 21 pieces of 6mm aluminium, 205 by 205, and 21 pieces of 3mm aluminium, also 205 by 205. All need marking out now for the hole in the centre, and also the positions for the 12 holes that hold all the spring steel wire. Here's the prototype one. I've got to make 21 of those. First thing to do is mark the centre of the plate and then centre dot it. Scribe a circle 200mm in diameter. This is the outside diameter of the support ring. The next compass is set to scribe a circle of 180mm in diameter, and this is the centre line of the holes for the spring steel wire. The third compass scribes a line 160mm in diameter. This is the inside diameter of the support ring. Centre lines next, and then centre punch where the wire holes are to be drilled. 1 down, 20 more to go. Base and support ring. Now eventually these two items will be held together by 4 M5 screws which will come through the base into the support ring, which is going to be tapped M5. Now I want the base to fit on in any of the 4 positions. So for that to happen, the holes that go through for these M5 screws have to be accurately machined. So what I'm going to do is temporarily connect these two together with 2 extra fixings here. Once they're together, I'll then assemble these to the rotary table on the milling machine and then machine the 4 holes which will hold the M5 screws that will hold these two together. If I do it like that, then this should fit on in any of the 4 positions with no problems. All 21 support rings have now been marked out. The 12 holes which will take the spring steel, they have been centre dotted, so that's all ready to go. Next operation is to temporarily screw the base to the support ring. Just set up the rotary table on the milling machine, and the centre of rotation of this rotary table is now directly underneath the centre of the milling head, which is here. The assembly of the ring unmachined, and the base is now on the rotary table. It's right in the centre, because if you remember, the this top piece of material, the 6mm aluminium, was centre dotted right in its centre, and the centre of the milling head, which is there, has been pushed into that hole. So this is now right in the middle of the rotary table. Sandwiched between it is a piece of wood. That's there because I want to drill holes in here, and I don't want to damage the rotary table, so the drill will go into the wood. It's clamped into positions here and here. I know whereabouts I want my 4 holes. The 4 holes we're going to drill are the holes which will be the fixing screws for the base, which is a 3mm bit of aluminium, into the support ring, just there. So the next thing to do is drill the hole and then wind this handle 30 times, and 30 rotations of that is 90 degrees on the table. Drill the hole, which is going to be a tap-in size for 5mm, for M5, sorry, which is 4.2. And then once that's drilled, I will then wind the handle on another 30 turns, drill another hole, and so on until we get our 4 holes, and they're all going to be exactly 90 degrees apart. I've put the chuck in the milling machine now, and also a centre drill here. I've moved the table 90mm in this direction, which has taken the centre of the milling head from the centre right the way out to the 180mm mark here, 180 diameter. So it's 90mm across. And now I've moved the handle, drilled the second hole, moved the handle again 30 turns, drilled the third, and I'm just about to drill the 4th hole. And that has drilled the start of the hole using that centre drill. Now I have the 4 holes all centre drilled. I'll put the 4.2 drill back in the chuck, go round again and drill all the holes right the way through into the wood 4.2 millimeters, which is the tapping size for M5. All 21 of the base ring assemblies have now been drilled with their 4 holes for the fixings. I'm now taking out the temporary fixings, which were in these 2 corners, and separating the bases to what will become the dome support rings. I'm now tapping the support rings, M5. I'm using the drill. We're quite close to the camera here, so it's going to look as though it's not square, but I'm taking a lot of care to make sure that the tap is nice and square to the surface. And we'll tap in, reverse, tap out. Just like that. Another one down. We have 4 holes in the base plate to countersink. Let's turn it off. And let's see what it looks like. I can feel with my thumb, that's nice and flush. Next job is to cut the centre of the ring out. Okay, we're ready to set up. Now the clock will go clockwise if that centre rises, and it will go anti-clockwise if the centre falls. So if I spin the job around, we can see it's gone clockwise. So it's high at that point and it's low at that point. So these 2 jaws, which are in line, so it's low and high. So the high one I will tighten just a little, see if it moved. Now they are both tightened up. Let's come down a little, and I'll go down to the bottom, which is showing low, and I'm just going to crack it just a little because it's just a few thou we're talking about here. Tighten up this one. You keep doing that until it's on 0 all the way round. So we are now within half a thou. This is an old parting off tool I've modified to cut out the centres of the support rings. It will be plunged into the face of the support ring to cut a groove, so I had to relieve this side of the tool just here, so it didn't rub against the inside of the groove it was cutting. The cutting edge is 2.5 millimeters, that's 3/32 of an inch wide, and it's 7 millimeters, that's 9/32 of an inch deep. This image is looking straight down on top of the cutting tool. I've ground the end of the tool at an angle. It ensures this corner will penetrate the job first, leaving the centre of the ring being cut out with a flat edge. You can see here the tool being plunged into the face of the support ring. I take it very easy and use cutting oil applied with a toothbrush. There is a bit of chat as you'd expect, but the tool cuts well. I've been using cutting fluid in the groove that's being formed to try and clear the swarf as it builds up on top of the tool. I've also been looking at the compound slide scale as I've been advancing the tool in. Now the material is 6.5mm thick. I've gone in 6.5mm, but as I got close to the 0.5 mil, I was looking on the back of the plate, and you can see here that there is a witness of it's actually a bulge on the back of the plate where the tool is about to break through. I am actually cut through, but there's plastic film on the rear, and the plastic film is stretching. So if I push my fingers, can you see the middle moving? So we are through, and that is one disc, 160 millimeters in diameter, and cut off fairly cleanly. I have my small boring bar now mounted in the lathe. It's all set up correctly on centre height, and we're now going to bore out the centre of this hole to 160 millimeters. We want to turn this hole out now to 160 millimeters. Unfortunately, my digital calipers, they only go up to 150 millimeters. So I've had to dig out my old vernier calipers. Because we're making an external measurement, we have to take into account the thickness of the 2 bits at the end, which I happen to know is 10 millimeters. And that is it. That is the measurement. So we read what the vernier says, and it shows 14, so we've got 140, there's 150, so 149.8. So 49.8, so we're only 2/100ths of a millimetre off. So that is actually good. What I have to do is deburr it. All 21 dome support rings have had their middles cut out. The 160 millimetre holes are all here, a whole pile of holes. Now all the holes are out of the dome support rings. I need to get rid of the sharp corners, and I'm actually going to turn these off. And I'm going to turn this into that, which looks far more ringy than what this does. And the way that I'm doing that, I'm turning it off in the lathe. I've fitted the lathe with its largest 3-jaw chuck, and I'm using the outside of the outside faces of the jaws here, expanding the chuck to hold it, and then coming in on the outside with the same tool that I use for cutting out the 160 millimeter hole in the center. I'll get this set up and I'll show you how it looks. Okay, the ring is locked in the chuck, the tool's ready to go, and it's also set. All I need to do is plunge in to cut it all off. I've obviously got to be careful because this is 6 millimeters thick, and as I get towards the end I don't want these flying off. I've got my foot on the emergency stop, and let's see how it goes. Right, that's 5.8 millimeters, and they're wobbly. That's good enough. And this is the ring, hot from the press, as they say. And now all I've got to do is take a pair of pliers and there we go, and snap it off. One. Let's pull this backing off. Pliers. And there we go. The outside has got to be turned down. I'm going to do that together with the base once they're screwed together. I carry on till all the support rings have had their corners cut off. Next job is to drill the 12 holes that will hold the wires at the correct angle in the support ring. We're looking at a part of the support ring just here and the ends of some of the wires. Now there are 6 wires, which gives us 12 ends, and to get the correct curve on the wire, those holes which take the wires have to be drilled at a certain angle. If I put this piece of paper here, you'll be able to see the wire a little bit easier. Now the centre wire, remember that these wires are in groups of 3. The centre wire needs to be drilled at 67 degrees from the vertical, and the 2 outside wires were 65 degrees from the horizontal. Well, I did a bit of experimentation and I found if I cut them all at 65 degrees, then the angles worked out fine and gave us the correct curves on the wire. So what I needed was a drilling jig to hold this ring at the correct angle so I could drill these holes all at 65 degrees from the vertical. And this is that very jig. If you notice that it's wedge shape, it's built at 25 degrees between the flat surface of the bench and the top surface of the jig. Now then, with this being at 25 degrees, that means it's now another 65 degrees to the vertical here, which is the angle that we require the holes to be drilled at. If we turn it round to the front, you can see that we have this V section here, and if I grab hold of a support ring, that slides in and it's actually held quite nicely between those 3 different points. We need to make sure that it's in the correct orientation, so there's a line with one piece of masking tape there which you align with the centre hole. Once that's aligned with the centre hole, then you can drill any one of the 3 holes up here. Once they're drilled, you then turn it around 90 degrees and you can drill the next 3, and so on. We're now going to start drilling the 1.2 millimeter holes in the support ring. The centre dot is quite large compared to the drill. The drill is only 1.2 millimeters in diameter, so it fits into the centre dot even at this angle. So I'll turn the drill on and we'll start to drill. I'm applying a little bit of lubricant with this little screwdriver. I've tried a brush, but the brush brings in too much and it goes bloop and there's oil all over the place. Right, let's start drilling a hole. Line up with the centre dot, straight in the hole, and start to drill. A little bit of lubricant. I come in and out of that hole lots of times because I don't want the swarf to get bunged up in the flutes of the drill in the hole. And we're through. There are 21 rings to drill Each ring has 12 holes, so in total I've got 252 holes. Well, I just drilled a couple of holes, and it takes between 30 to 45 seconds a hole. So let's look on the bright side. Let's say 30 seconds. So that gives me 252 divided by 2 is 125, 126 minutes. Well, 120 minutes is 2 hours. So 2 hours and 6 minutes looking on the bright side of drilling holes. That's if nothing goes wrong, if I don't snap off any drills. So I'm going to be doing this for a little while. All 12 1.2mm diameter holes have been drilled in the support ring. The next job is to mount the support ring back on the base. Stick these together using their fixings, which are the M5 socket head countersunk screws, 8mm long. That will give us an assembly which looks like that. So the next thing to do is put the job on the chuck. Now here is the support ring and the base screwed together. The top surface of each of the 4 jaws are going to go against the surface, or the inside surface of the support ring. So that will go on like that. I will then, in effect, unscrew the chuck. The jaws will come out and clamp against that landing there. Once that's set up and nice and tight, I'm then going to plunge into the front face with the same tool as I've used for the other boring. And hopefully it will work. So I'm looking at the subscale, or the scale on the compound slide. And I won't be going any more than 3mm. And that, look at that, a very, very close. Now we'll see if we can snap them off. I've just taken the job out of the chuck, and you can see the corners are still quite solid, but when you bend them, ping, they snap off. Ping, and snap off. And that's going in 3mm, which is the thickness of the material. That works quite well. Right, let's do the next one. All the support rings and base assemblies, I've had their corners cut off and they're all looking nice and round. The next thing is to put it back in the 4-jaw chuck, clamp it in and turn the outside diameter down to the finished diameter. I have all 21 support rings here on the desk. The 1.2mm holes are drilled and in position. The inside diameter and the outside diameters have been machined. That's correct. The next thing to do is make the fixings for the spring steel wires. You remember that here's the prototype. Those 1.2mm holes are for supporting these wires. Now the ends of the wires go down into the hole, and we need a way of fixing those spring steel wires in the hole, and we do that with an M3 grub screw. So all of these rings in 12 positions on each of them has to be drilled and then tapped M3. Let me bring you down here and I'll show you what we're going to do. Here's a close-up of the prototype with its 6 spring steel wires. Now you see that the wires come down and they go into the top surface of the ring just here, and they are held in position by grub screws which come through the side of the ring in that plane there. 1, 2, 3, and here 4, 5 and 6. Now what I have to do is mark those positions out on the new ring, and that's the next job. And we do that with this little square, so I can see the scratch on the top, mark an outline there, so I'll get the square in line and bring it down. 1, 2, and so on, just like that. The 12 lines are now marked on the edge of the ring, and to centre dot them I estimate the centre. It's 6mm wide, so I can fairly easily gauge the centre and centre dot. 1, 11, 12, another ring marked out. I'm drilling the holes now for the M3 grub screws. I will be using my trusty cutting fluid toothbrush, the brush does two things. The fluid going onto the drill cools it down and lubricates it, but also as the drill's turning, the brush tends to pull out any swarf that's stuck in the flutes. It's wandering off just a little, so I will just touch it. Now I can feel that we've got a nice flat surface. I've got the stop set up on the drill, and it's set to stop just after the 1.2mm hole. And then that way I should be able to tap right the way down to the hole. I felt it go through the hole now, and it goes down just a millimetre or so the other side. And that's one hole drilled. I now advance this on 3 holes. There's 1, 2, 3. Still drilling holes in these support rings. I've now drilled the 8 holes which are off-center. If you remember, they're in sets of 3, so there's 3 on each segment of the ring. The 2 outside holes have been drilled, 2.5, and I've now changed the setup here so I can get to the center ring. So with 21 rings, 12 holes, I've now drilled 168 out of the 252 holes that I've got to do. So I've only got 84 left, so I should finish this in a couple of hours. I've got 12 holes to tap in each ring. I have 1 power tap, which I'm hoping isn't going to break, but unfortunately it's not long enough to get to the bottom of the hole. So I'm having to tap them twice, once with this tap, and then when I get a batch finished, I'll then swap it over to my normal tap and run through there. Fingers crossed that it's not going to break. Let me bring you down, you can have a look. I have the machine tap in the drill. I've got the drill set on just 2, which means it is very light. And that's because I'm so worried about breaking the tap. Cutting fluid in the tub here. And this is what I've been doing. So into the cutting fluid. And one, get rid of the swarf from the drill into the cutting fluid. 2, into the cutting fluid. You get the idea. At last, it's assembly time! All 21 rings have their 12 grub screws each. All have been deburred, de-oiled, and are now waiting for the spring steel to be cut to size, stuck in the hole, and then held in position by doing the grub screws up. Right, I'm cutting the spring steel now to make the loops on top of each of the units. Now I need 4 lengths at 355 and 2 lengths at 385. I've got the lengths drawn off on the edge of the table here, and a block of aluminium for this to for the wire to butt up against, so I can butt it up against there, get my cutters and find the 355, which is there, and a 1 and 2. Now unfortunately I had to buy the wire in lengths of 1 metre. I can get 2 of the correct length, and I have a bit left over. So that will go into my offcuts tray, and you never know, I'll be able to use that later. We're on the home stretch now. The spring steel is all cut and waiting to be assembled to the rings, and then the base is to be assembled to the bottom of the ring. I've just finished 1, 2, just to make sure everything's okay, and it is. So let's get to number 3. This is the assembly procedure for one of the windjammers. This is the support ring. The first thing I do is screw the base onto the support ring. Now, all the spring still is cut. I've got 2 piles down here. Now, you remember that the holes in the support rings are in groups of 3, and the 2 long wires, they go into the center of each of them. So it goes in there and there. That's the first one in. And now we tighten up the grub screw, get the next. Now the next to go in are the short lengths, and the short lengths go each side of the 2 hoops we just put in. So this is woven, that goes underneath this one, so this one goes on top, underneath, on top and into its hole. And we do the same on this side, over the top of the first one, under the second, top of the third one, it goes down into its hole. Like that, and tighten it up. So we just check that we've got the weaving bit right. Under, under, over, over, under, over, under, over, under. So that's all okay. And that is a finished windjammer. And there on the workbench, the skeletons of 21 windjammers, all ready for their foam domes and then their furry covers. And that is the next job. The foam domes fit quite easily because the dome actually comes back on itself. It's a smaller diameter at the bottom than a third of the way up. So when you put the dome on and just wobble it a little like this, it goes over the tight patch, and there it is in place, just like that. Time now for the furry covers to be fitted. And there they are, 21 completed windjammers, all ready to be delivered. I can't wait. Phew, that was hard work. Well, the windjammers are finished. They have been delivered to the customer, and they were delivered early, which pleased them no end. And testing is underway. Could you do something like this? Of course you can. And with that, this video is at an end. Take care, everybody. I'll see you next time. Could you do something like this? Of course you can.